All right, guys, so we're diving into a chapter where we're going to have to do something called solving systems of equations. Okay, and you can obviously see that first way we're going to talk about is we're going to solve them by graphing. Okay, a system of equations, first and foremost, okay, is when you have two or more equations. Okay, and they work as a system. Now, what that means, guys, okay, if you think about what a system is, all right, so for example, like a football team is a system, a band is a system, okay? Um, Way back in the day, and probably even still today, but there was the assembly line. That's a system. They use assembly lines to make cars. You know, they put the engine in, they put the transmission in, they put the wheels on piece by piece. Everybody had a job, okay? On a football team, right? Okay, there's 11 players on the field at a time. Each player has a job. Okay, if one or two of those players don't execute their job, well, the play might not work. If you're working in an assembly line and one or two people don't do their job, well, they're going to put together a car that's not very good, and somebody's going to get hurt. Somebody's going to get in an accident, or that car is not going to pass inspection, or whatever the case may be. So a system is when you have things working together to accomplish a goal. Okay. For our purposes in math, okay, a system is going to be when you have equations that are working together, they have the same solution. Okay. And we're going to talk really briefly right now about solving systems by graphing. We're going to get more in detailed with the other methods. So I just want to show you why the answers are what they are visually, because some people like to have a visual. Okay, so when we talk about graphing, in number one, your system would be these two equations. So those two equations are going to work together, meaning the answer is going to be the same. I'm going to graph them separately. This is slope-intercept form. We talked about that last chapter. Okay, so this equation would have a y-intercept of 0, comma, -3, which would be right there. Okay, and then a rise over run of 1 over 2. So from that, rise 1, run 2. There would be my second dot, rise 1, run 2. I want to go backwards, down 1, left 2. All right, so your first line is going to look something like that. Now, we're going to graph that second line, okay, which is going to have a y-intercept of 0, comma, -1, which is right there. And this one's going to have a rise over run of 3 over 2, which means from that green dot, I'm going to rise 3, run 2. Now, if we were in class right now, I would ask questions about, what do you think is going to happen here? How are we going to figure out where the solution is? Um, Obviously, I can't ask you that right now because I'm not in front of you. All right, but as I'm finishing this problem, I want you to think about what's going to happen. What do you think is going to happen? What should happen? And then obviously in about 2 seconds, we're going to find out what that is. So think about that for a second. Okay, now I rise 3, 1, 2, 3, run 2. There's my next point, rise 3, 1, 2, 3, run 2. If I want to go backwards, 1, 2, 3, 1, 2. You probably are seeing now what happens. My green line looks something like that. Okay, what do you think the answer is? Well, that's why I wanted to give you a visual, guys. The answer is the point where they cross. So that point is going to be the answer to the question, and that point is -2, comma, -4. So the solution to this system is going to be the ordered pair -2, comma, -4. Now, what that means is if I took that ordered pair and I plugged it in here for x and y, and I plugged it in here for x and y, that ordered pair is going to work for both equations. That's what makes it a solution to the system. Okay, if I take a look at number two is given to you a little bit differently. This is in standard form, but it's the same concept. So if I took that first equation, right, that 5x plus y is equal to 4, and I rewrote it in slope intercept, I would minus 5x minus 5x. Okay, that would be y is equal to -5x plus 4. That equation is going to have a y-intercept of 0, comma 4, okay, which would be right there. And it's going to have a rise over run -5 over 1. So that means I'm going to go down 5, right 1. 1, 2, 3, 4, 5, right 1. Okay, I don't think I'm going to be able to fit another point. So I'm going to draw my graph. Okay, that second equation. Okay, if I subtracted x across from each side, again, I'm going to rewrite it. Okay, these would cancel. That would leave me with negative y is equal to negative x plus 2. And I divide it across the board by negative 1. Okay, I will have y is equal to negative divided by negative is a positive, minus 2. So that's going to have a y-intercept of 0, comma, negative 2, which would be right there. Okay, and then your rise over your run for that graph is there is no number, so that makes it a 1 over a 1. Rise 1, run 1. There we go. There's my point. I can keep going if I want, just to make it look a little bit better, but I got what I needed. I found out where they crossed. Okay. Here's where they're crossing. Whoop. That's where they're crossing. So that's our answer. Okay, so the answer to this one is 1, comma, negative 1. And again, if I took that ordered pair and I plug them into those two equations up top, they're going to work for both. Okay, so what I always do is when we talk about these graphically is I think about intersecting roads, right? So like outside of our school, outside of Jackson Liberty, you have Hope Chapel Road and you have Veterans Highway. Okay, so they cross right out by the Wawa. So you're going to be on both of those roads if you were standing right in the middle of that intersection, which obviously I don't advise that you do. Okay, but that's where you're going to be on both roads at the same time. So graphically, that's kind of the best analogy that I can come up with.